model of the track leads to the wear penalization. The track, the impact leads to the real vibration of the third model, cause the wear penalization. Sorry.
Next one.
Okay. I want to stress the importance of the simulation for the polygonal wear because I have read a lot of papers giving lots of reasons, but there is no simulation for the polygonal process, and I think this can help us to validate some hypotheses. So I think this is a quite important part, but to be honest, I'm not very satisfied with the simulation model I built in my paper, and I find I have mentioned. Sorry, the time will be longer. I have mentioned some factors, but I did the effect of these factors qualitatively, and so maybe in the future I hope I can get some measured data to improve this polygonal wear simulation method. Okay.
Wubing.
Hello. In our paper investigated the mechanism of the high-order polygonal wear in the China's high-speed line, and through simulation and experiments, the results show that the third-order rail bending mode between the wheel may be the more possible explanation.
Dadi.
By the experimental investigation into the out-of-roundness of the wheel, we regard the P2 resonance between the wheel and wheel is the origin frequency of the wheel out-of-round roughness.
Okay, now we have more time to discuss for this topic. Any question and comment? Yeah, please.
It is just a comment. In fact, there is this afternoon you have 3 papers on wheel corrugation, and 2 days ago we have also some discussion about rail corrugation, and Mrs. Wang, who is here, spoke about standing wave in the rail. So what is of interest is that in China you have quite flexible fastening system.
Yes.
Then you have natural frequency of the rail in between the 2 wheels of a bogie, and this has an influence on the wheel polygonization on the one hand, but also on rail corrugation on the other hand. And these are the 2 sides of the same coins. And that of interest because in Europe we were not accustomed to that because our rail fastening systems are usually stiffer, and then these bending frequencies of the rail are much more damped, and we don't have to cope with this trouble.
Yes.
Okay, so this is just a comment.
Yes, through
Very important.
Through our simulation, the parametric studies, if the stiffness of the rail pad or the damping of the rail pad is larger, the high-order polygonal wear will disappear, or the growth rate will suppress. Yes, I agree with you. Yes.
Yes. Okay.
Thanks thanks very much for your presentation. I have one question for Ubin that I think, if I understand correctly, that your suggestion is that if the velocity of the track line keep the same, that will make the track degrade more?
No. Change more frequently.
Yeah.
Not always keep the constant speed.
So which is better if the velocity is
changes frequently will better.
Is better.
Yes.
But how can you do that? Because that should be the velocity should be stable in line, right?
Yes, we can. In China, the vehicles is always run in before. So the vehicle usually operates in the same line. So we can now we can make the vehicle operate on the different lines, and the frequency may be change more.
Okay, thanks. And also one
more. Some lines is 300 kilometers per hour, and some lines is 250 kilometers per hour. Yeah. So.
Okay. So the variation should be like 50 kilometers per hour difference.
Yes, it's enough. It's enough.
It's enough to improve it. Okay,
yes.
Thanks.
Dr. Klaas, I remember you have a question for the first.
All right.
Any more common question? There are different reasons to cause the polygon from different research groups, also in our laboratory. But it's a very difficult problem in recent years occur in the Chinese high-speed train. So I can say it's some work is under investigation now. It's not the sufficient time to conclude a positive conclusion, maybe.
I think it was the third presentation, but showed that there were 4 modes with the bogie rather than a single wheel set. There were 4 modes underneath 1,000 hertz, but only one of those actually gave rise to the corrugation.
Yes.
And am I right in thinking that was just because it keyed in the wear from one wheel set keyed in with the wear from the second wheel set?
Keyed in?
You got wear from the first wheel set, and the second wheel set was in phase. The wear was in phase.
Yes.
But for the other 3 modes, the wear was out of phase.
Yes.
So the other 3 modes didn't give corrugation, but one mode did give corrugation, or wheel corrugation.
I'm sorry.
No, okay.
So can you?
Somebody showed a picture of 3. There was a single wheel set, and there was a bogie.
Yes.
And with the bogie, you had 4 peaks in the curve underneath 1,000 hertz. And
Yes.
one of those was at 580 hertz. And only 580 hertz resonance caused irregularities.
Yes.
And why don't the other 3 cause irregularities?
This is a good question, and I was thinking about. I want to explain. Maybe the damping ratio of this mode is different. Like the first speaker choose presentation. The first bending mode, the damping ratio of the first real bending mode is larger because it's like this, and all the real pad is point, and the damping ratio is larger, I think.
The higher the mode order, the lower the damping. The first mode is more damped. Then the second mode is a little bit less damped. The third mode is less damped, as you have shown in your first presentation.
Yes.
You have shown the modal damping. Because when you go up in frequency, you have more potential energy in the rail and less in the pads. So the pad provide less energy in the
yes.
system, and the global damping is lower. So it's normal that the higher modes will be more excited than the lower ones.
Yeah.
More question? If no more, then we save 3 minutes. And let's thank our 4 presenters again. And also thank all of you for attending this session. I now close the session. Thank you.